Hi guys, welcome. So yesterday we talked about significant figures and we got to know certain rules which clarified our thought with respect to significant figures and significant digits. Now today let's start with rules for arithmetic operations with significant figures. Okay. So generally the result of a calculation involving approximate measurement or approximate measured value of quantities must reflect the uncertainties in the original measured values. It cannot be more accurate than original measured value. It means that, let's say I have density is equal to mass upon volume. So let's say the mass is 4.237 grams and the volume is 2.51 centimeter cube, right? So what will be the density? So we have to write the density as 1.69 grams per centimeter. So what we have done here, we have taken this only two places of decimal, here two places and here it is three places. So what this statement says, the result must reflect the uncertainties in the original measured value. So whatever is the uncertainty, okay, this is the uncertainty in the original measured values. Okay, so this we have to take as the uncertainty in the final result as well. It cannot be more accurate than the original measured value themselves on which the result is based, right? So read this: in multiplication or division, the final result should retain as many significant figures as there in original number with least significant figures. So here it is least significant figure, that is why we are taking only two places after decimal. So here total is three significant figures, that is why our answer will also come with three significant figure only, right? This is the concept. Now the second, what happens in addition or subtraction, right? So for example, we have two numbers, okay, we have two numbers 4.3436.32 grams, right, 227.2 grams and 0.301, right? So this is the addition has to be done. So generally if you do addition, what will you get? You will get 663.82 grams, right? But while representing this in terms of significant digits, the final result should therefore be rounded off, and since this is having digit after only one digit after decimal place, hence we have to make it like this: 663.8. So this is about addition. What about subtraction? Let's say we have two numbers 0.307 meter, we have to subtract 0.304 meter. Okay. So what is the answer? 0.003 is the answer. So now these zeros are non-significant, hence it has to be written like this: 3 into 10 to the power minus 3. This is how we have to write. Okay. Now the next is rounding of uncertain digits. Rounding of uncertain digits. So the result of computation with approximate numbers which contain more than one uncertain digit should be rounded off. What it means? Let's say we have the number 2.746. So how we have to round it off? So you can round it off like this: 2.75. If this is greater than 5, if the last digit after decimal point is greater than 5, then we have to round it off like this. And if it were 2.743, then we would have written as 2.7 like this.
Now, what if the number is 2.745? So, when the last digit after decimal point is 5, then you have to consider certain aspects. So, what aspects? You have to check the preceding digit. If the preceding digit is even, then you have to simply drop the last number. So it will be 2.74. On the other hand, if the preceding digit is odd, then you have to raise the preceding digit by 1. So you have to raise this by 1. So 2.74 it becomes 2.74. So this is the concept. So whenever there is this middle number, then you have to always go for checking the preceding digit. If the preceding digit is even, then you have to simply drop this 5 drop. And if this preceding digit is odd, then you have to increase it by 1. So 3 becomes 4. So 2.74.
So let's do certain example. Each side of a cube is measured to be 7.203 meter. So this is the cube. This measures 7.203 meter. What are the total surface area and volume of cube? To appropriate significant figures. So surface area is 6 into side square. 6 into side square is the total surface area. So 6 into 7.203 meter square. So it comes 7.203. So it comes equal to 311.299.254 meters. So appropriate significant figure will be 311.3. Why? Because it has got 4 significant figures. That is why answer should also have 4 significant figures. Right? What about the volume? Volume is side cube. Volume is equal to side cube. So it is 7.203 meter whole cube. So what is the answer? 373.714. So what is appropriate significant figure? So since it has also this only four significant figures, that is why we have to consider 373.7 meter cube. Now let's do another question. So 5.74 gram of a substance occupies 1.2 centimeter cube. Express its density by keeping the significant figures in view. So what is density? Is equal to mass divided by volume. Okay. So mass is 5.74 gram divided by 1.2 centimeter. So what is the answer? Let me just calculate. 5.7. So it is coming 4.7833 gram per centimeter cube. So how to express it in significant figures? So it will be 4.8%. Why? Because denominator has only 2 significant digits. That is why the answer should also have 2 significant digits. Right? So what was the rule? The rule is this. Now, what is the rule for determining the uncertainty in results of arithmetic calculation? So, what are the uncertainties? Now, rules for determining the uncertainty in results of arithmetic calculation. Let's say we have this rectangular sheet. Length is 16.2 and breadth is 10.2. So, we have basically three significant figure in each measurement, right? So length can be written as 16.2 plus minus 0.1 centimeter or 16.2 centimeter plus minus 0.6%. So basically we are converting this into percent. So we are converting this to percent. Now what about breadth? Breadth can be written as 10.1 centimeter plus minus 0.1 centimeter, which can be written as 10.1 centimeter plus minus 1%. Now what is the product of length and breadth? So L into B equals 16.2 into 10.1. is 163.62 plus minus what is the percentage? So in case of two quantity getting multiplied, we have to add the percentage error of the uncertainty. So 0.6% plus 1%. This is the uncertainty we have to add. We have to add the uncertainty. So it becomes 163.62 plus minus 1.6%. Now calculate 1.6% of this total. How much it comes? Okay. So how to write? Just apply the rules. So it will become 164 plus minus 3 centimeter square. This is the final answer. So what is the uncertainty or error? Error is equal to 3 centimeter square. This is the error. So 3 centimeter square is the uncertainty or error in the estimation of area of rectangular sheet. Right? So this is how it is calculated. Now second is, if a set of experimental data is specified to n significant figures, a result obtained by combining the data will also be valid to n significant figure. Now what it means? Let's say we are subtracting two masses, 12.9 gram minus 7.06. So both have three significant figures, right? So it can be, but since there are mismatch in the decimal places, like there are two numbers after decimal place and here only one number after decimal place. So if we subtract it, generally we will get 5.84 grams as the answer. But as per the significant figure theory, since this is having only one digit after decimal place, we have to make it, the final answer has to be one digit after the decimal place. So this is the answer. Now the third is, the relative error of a value of number specified to significant figures depend not only on n but also on number itself. What it means? Let's say for example the accuracy in measurement of a mass 1.02 gram is plus minus 0.01 gram, whereas another measurement 9.89 gram has 0.01. So what is the relative error? So what is the relative error here? It will be 0.01 divided by 1.02 into 100, right? It comes as almost equal to plus minus 1%. What about relative error in 9.89 grams? Here, so 0.01 divided by 9.89 into 100, it will be plus minus 0.1%. So it is 10 times lesser, right? That is why the relative error of value of number specified to a significant figures does not depends not only on n but also on number itself. Okay. Now what about intermediate multi-steps calculation? So one thing we have to keep in mind that we have to keep at least one extra significant digit. Why? Because while doing calculation in a multi-step computation, rounding errors can build up. Okay, can build up. Let's take an example. We are taking, let's say, reciprocal of 9.58. So 1 upon 9.58. Okay, so this comes to, because this is three significant digit, so 0.104. Okay, but if we again reciprocal it, then how much it is coming? 9.62. If we would have written the reciprocal to 0.1044, so it means one extra significant digit we have to take. So if we take 0.1044, then we get 9.58 after reciprocating 0.104, right? So one extra significant digit we have to take during the multi-step calculations, right? We will take the topic dimensional formulas and dimensional equations. So stay tuned guys for tomorrow's lecture, physics 11th class CBSE, dimensional formulae and dimensional equations. Thank you very much.